Welcome. Thank you that I'm allowed to be a guest here and to talk to you. We will talk, as I will talk about the changes in the pharmacopoeia, the methods. The pharmacopoeia, there are two big books. The one is the United States pharmacopoeia, and then there is the European pharmacopoeia, which both are typically harmonized with each other for the most important things. There are also other pharmacopoeias like the Japanese and the Chinese. However, we here in Europe, we mostly work with one of these books or with both books unless we export our products to Japan or to China. And the big revision that happened in these books is affecting the general chapters of chromatography, the 621 in the USP and the 2246 in the EP. Inside these chapters is written how you make calculations, like how you compute the tailing factor, how is the signal to noise calculation done. There are also rules outlined what you're allowed to do when a method does not perform in your lab, like can I change the flow rate, may I change injection volume, all these things are there. And there are two more chapters, the 526 that is added in the European pharmacopoeia with January. It's about how to implement a method to your lab, a new method from the book. And in context of this one, I also reference the 1220 chapter in the USP about analytical procedure life cycle, which is mainly talking about developing a method and controlling a method on the long run. I have it here in a grayscale color because the chapter 1220 is already effective in the USP, whereas the black ones are coming. So in USP, by December 1st, we have to follow the new rules, and for the European pharmacopoeia, by 1st of January next year. And therefore, by 1st of January, they are also harmonized again. So what was the change? What is new? The biggest change from my perspective is that we are allowed to convert any method from the book, means monograph or compendial procedure, to UHPLC, or if you like to say UPLC conditions, without revalidation. Of course, only as long as we play according to the rules that are outlined in the chapter. I will explain them and will guide you through how to change the method. The second big part are calculations. I mentioned it before, how you compute the tailing factor, how you compute signal to noise. Here, big changes have happened. The biggest change is that the tangent method to determine the width of the peak is no longer used. So when we calculate theoretical plates, which is often a system suitability criterion in a method, we need to use the half-height approach. A peak at 50% of the height, we measure the width, not the inflection point anymore. And the same applies then also to resolution and relative resolution. Also here, half-height approach has to be used. The tangent width is no longer effective. Also, a small detail, theoretical plates have been renamed to be now plate count in both books. So if you have a report, please say this is a plate count, not a number of plate. The tailing factor did not undergo any change in the formula, but the term tailing factor is removed from the USP. So we are in both books only talking about symmetry factor in the future. And if your symmetry factor is below 1, the peak is considered fronting. If the symmetry factor is above 1, the peak is considered a tailing peak. Factor 1 is preferred, that would be the perfect Gaussian peak shape. And the last point, signal to noise calculations. We are going back to 20 times the width of the peak. That was a long time ago in the pharmacopoeia. It was changed many years to be 5 times the width at half height of the peak, and it's now 20 times. When you run a method from the book, of course, it's logic for the new procedures you do as outlined on the right side in the section effective soon. Challenging and tricky it gets if you run in-house methods that reference to the pharmacopoeia. So imagine you made an analytical procedure many years ago and you wrote, we calculate our signal to noise at detection limit and quantitation limit according to the book. And you did the validation according to the book many years ago. You most likely did not use 20 times the width. Yeah, and now you run the method in routine in your lab, and it's written probably in the analytical procedure according USP. You have to do it without the formula. Then you would need to take measures, and you should take them soon. Check if you have such, call it Easter eggs in your lab, and take please the appropriate measures to update the procedures to be still get the right results or change the specification acceptance criteria of the methods. So it will certainly involve change control when you're in a regulated environment. Changing the methods from HPLC to UPLC condition, or here just in the general term UHPLC, is easy, but there are some small things that we need to consider. The most important thing is the internal volume of the instrument. Yeah? We have a mixing volume at the beginning where the gradient composition is formed, and later, after the peak elutes from the column, we also have another volume, we call it the dispersion volume, where the peak gets border. Yeah? So with the tubing that is used on the instrument, with the cell volumes, you change the peak shape. Yeah? In LC, on the left side, we typically have more than 1 milliliter mixing volume, and our flow cells are in the microliter scale. On the complete right end, like on an eyeglass, we are in microliters mixing volume, and the flow cells are in nanoliters. Yeah? And this is, of course, a big impact. You can compare it with, small pipe and thin one. You get the sharp peak or you get the broad peak. Yeah? So the column that you use should match the instrument. We may convert the method to any of the other platforms, from LC to entry-level UHPLC, 600-700 bar systems, or we go to the true UPLC systems. We are working here close to 1,000 bars, typical sub 2 micron. And by doing this, by going to the smaller particle, we gain speed, we gain resolution, we gain sensitivity. Yeah. As an approximation, if you need to run a related substance and assay method, you might be more than 10 injections. If the injection is an hour, you need at least 10 hours to run the method. So most likely it will run overnight. You load the samples, you start it on the next day, you look on the result. If something went wrong, you're gonna need to repeat again the test. If you would do the same method on the UPLC, the runtime would drop to about 10 minutes. So your 10 injections are done in 1.5 hours to 2 hours. You're finished with everything. If something didn't work, you could fix it immediately, resume, and still at the same day, you have your results and peace of mind. So how do we change the method? In the book is outlined what we are allowed to do, what we are not allowed to do. Very logical, the stationary phase we are not allowed to change. So if you have a C18 column, you can't now use a C4. If amide is required, you can't go for phenyl and so on. This is logical. The chemistry has to be the same because the column is giving you the selectivity to separate the components. But we may change the length, the dimension, and the particle size. And here we need to stay within a certain range of ability of the column to separate the compounds. We call this the L over dP, the length of the column divided by the particle size. And we may reduce a little bit by 25% the power of the column, but not too much, but we may increase much more. So we can say, okay, increase by plus 50%. Which is also nice, because if you have issues with resolution, you just take a slightly longer column or a little bit smaller particle, and the resolution problem will be solved. The internal diameter can also be changed, and with this change, the flow rate has to be scaled. Yeah? We need to keep the good flow over the column, over the particle. There's a function that's called the Van Demter curve, where the ideal flow rate gives the highest number of plates when you separate components. In the red color here, this on purpose in red here, caution is necessary when you move to different hardware, because in the UPLC technique, the peak can elute within a few seconds, not within minutes. So the peak volume is very small. Hence, you would need instrumentation that can preserve these small peak volumes and peak shape. Should not dilute it, should not add extra dispersion, not extra peak broadening. And therefore, the pharmacopoeia is asking, look on everything, cells, tubing, and so on the instrument. The flow rate, as mentioned, has to be adjusted. The adjustment is very easy for isocratic methods, and if it's a gradient method, there is a formula in both books, they're identical. you just type start conditions and it computes the end condition based on the particle that you use. The same applies for the gradient time points. Yeah? So we have like 0 to 1 minute equilibration, 1 to 10 minute elution would be then probably 0 to 0.1 minute and maybe only elution till 2 minutes, something like that. But the volume that you pump between each the time points expressed as column volume has to stay constant. And there's also a formula in the book that does the mathematics for you. Yeah? So very easy to do it. The temperature changes are also permitted to some degrees. That may be important if you have different column oven compartments. Yeah, because every manufacturer has its own specification, probably plus minus 1 degree in accuracy, a little bit more, a little bit less. Also, how old is the oven? Do you have active preheating or not? So we have here some flexibility too, if we need to adjust the temperature on the column slightly to make sure that it performs like it did 10 years ago on an old instrument, which is probably not available anymore on the market. Wavelength change is not allowed. It's logical, because if I have to look on red light, I can't change the wavelength to blue. I would be blind to detect the peak. So it has to stay constant. And the injection volume is also scaling down. It's logical. On LC, you might inject 100 microliters. On UPLC, it's typically around 1 microliter for a sample, or 2 microliters. That well volume, I mentioned it before, is the mixing volume of the system. You have large mixers on LC and small mixers on UPLC. And there are instruments that are somewhere in between both worlds with the mixing volume. Yeah? And this difference in this mixing volume can cause that a method performs correct or a method fails system suitability. If that happens, they say add an isoquatic hold step to compensate for the volume difference. It means you inject and the gradient had already started before, or you inject and the gradient still not starting, it maybe starts in 1 minute or half a minute. We have to compensate the volume pumped to be aligned. At Waters, we have one system, it's called the Acuity Arc UHPLC system, which helps us here in addition by providing different well volumes. So the instrument has in its pump different mixers that can be selected via a valve. And you can say, I need large mixing volume, or I need a smaller mixing volume. This is very nice because it reduces the duration of the isoquatic hold step if you need one. Yeah? The pH value and the concentration of salts are restricted. pH is plus minus 0.2 units. There was no change. That was always there in the book. And also in the salts, no change, plus minus 10%. Yeah. This is a danger point. Yeah. If you have a pharmacopoeia method that runs on a strong buffer, phosphate buffer, for example, 200 millimolar or more, you may decide not to move this method to true UPLC condition for 2 reasons. The first reason is that if you work with high concentrated salts on a narrow system volume instrument, and you forget to flush it properly after use, you have a certain risk of crystallization. It could be that in the lab at night it's cold, if there is no flow, it could happen, and we don't want something to crystallize in the system. Yeah? On the other hand, if you have very good SOPs in place and processes that after the method was performed, you with another sequence automatically flush the system, clean the column and so on, then it shouldn't be an issue. This is one aspect. The second aspect is the column itself. So not every column, not every UPLC column that exists on the market likes high salt concentrations. So using that can decrease the lifetime of the column. This is why here, if strong buffers are involved, I personally recommend go from, let's say, 5 micron to 2.5 or 3 micron, but not go to 2 micron. Yeah? Just to have less after troubles that could happen. Yeah? The pharmacopoeia says we should not be aware about our dwell volume to take care and make the isoquatic hold step. There is a procedure in the books how you do this. You run basically a gradient with an UV active substance. The column is not needed, and we just measure the delay time from the program time point, which is here in the middle, yeah, where the red point is, to when did the gradient really arrive in the detector. And if you know, okay, my flow rate is 1 milliliter per minute, and it arrived 30 seconds delayed, then I have 500 microliters volume difference. Yeah, this is how it's done. If you're a user of Empower software, we can automate that by adding some custom fields to the system. Of course, it's your responsibility to validate them, or your subcontractors to validate it for you. And then every system can run this method automated in an automated fashion, and you know your internal volumes. Yeah, which might be different depending on what oven you have, what detector configuration have, do you split flows, not split flows, and so on. So we know this now. Now we need to find the column. Of course, the column must be available in the smaller particle. This is not the case for every column on the market, so don't expect every method can be moved. And the column must match the description in the pharmacopoeia. As example, I took the method for nicotine. Here is a column inside, 150 millimeters long, 4.6 millimeter internal diameter, 5 micron, classical HPLC. It's end capped. We have the description here. You can go to the knowledge base in the pharmacopoeia. This is here on the left top, and can look up what column did the pharmacopoeia use to run that monograph or procedure. In most cases, there's only one column. Sometimes there are several columns mentioned. Doesn't necessarily mean that it was evaluated by them on all columns. Yeah, so they just give you suggestions. Yeah, you're not bound to this. So it's of course nice to see here. It's a Waters Xterra reverse phase 18 column, and I would like to sell it to you. But if there is a different one which matches the blue description on the bottom, the other column could work too. So if you have the case that you don't know what column to use, maybe the column does not exist anymore on the market, or you have issues with reproducibility, I'd recommend visiting our website. Use please Microsoft Edge browser, because this does not cause any troubles with our website. Yeah, so our website was optimized for the Microsoft Edge browser. Go to the support section and move the mouse down to tools and calculators. Here we find several interesting things. The first one is that there's a column coach where you can select any vendor column, and it shows you on a chart selectivity and hydrophobic of the column, where is your column located, and which column provides a similar separation. Yes, so you can pick the most close column. Of course, you have to stay within the same type of chemistry, so C18 has to be still C18, the alternate, and the ligands must also match. If you don't like to use such interactive tools and work with a kind of Excel sheet or lists, we also have that. If you navigate this path on our website, you get a list of hundreds of columns of all vendors, and they have been benchmarked at Waters, comparing with what is the closest selectivity that we have to this column for both particles, HPLC or UPLC separation. So you can give this column also a try if you like so. So let's say we found the column, and now we go to the web shop. That's what I would do. Yeah, whatever manufacturer it is, yeah, preferably Waters, of course. And we look, is this column available in the smaller particle? The easiest way is, of course, to use the filters, because once the column is selected, it will not show a sub 2 micron column if it's not there. So I know now for nicotine, I could use the 5 micron, 3.5 or 2.5 micron. I say I want to go with 2.5 micron. Then I open another tool. It's available on the website, but it's also built in Empower in the instrument method. It's called the columns calculator. And in this calculator, I file here on the left side the starting method. This is the original 5 micron column. And then I play here on the right side with the dimensions of the column, with length, particle size, internal diameter, and the software automatically calculates for me the length over the DTP. This column would be a perfect match, the same separation power, so the method should give the same, exactly the same results. If I go for a smaller one, like this one, method would be faster, runtime would be shorter, but it would require full validation. We did not comply because it's only allowed minus 25% in L over dp. So this column I reject, and I could also go with this column. It's a little bit longer, runtime slightly increased, maybe 1-2 minutes more to do the injection, but I get plus 10,000 L over dp, so I have more power of separation. So I end up with either pick the up top or the bottom right column. Sometimes the pharmacopoeia is nice. Sometimes not, sometimes yes. Now it is nice. It gives us a reference chromatogram. It's also embedded in the knowledge base. And I may review this and see how close are the peaks together. Yeah? If they're very close together, I might reject to decrease the L over dP. I might keep the same or increase it, trading the speed against resolution. I do not want that this peak here, we have here a split peak integration, about 10 minutes, runs together. So this is also an advice from me. If you doubt, take a little bit longer column. This 1-2 minutes don't hurt, but you for sure won't have any issues with resolution later. If there are no peaks in between and they very far apart, like minutes, go for the smaller one. Yeah, take the speed that you can get. And now we need to adjust flow rates according to the new column. So this was the European pharmacopoeia method. And then we have to do the mathematics. We have to convert this according to the formula. If you don't want to do this manually, it's embedded within Mpower. So when you have a quaternary pump instrument method editor, you can call the conversion function, and you file on the left side the start method, and it will automatically translate it to the new time points and new flow rates for the smaller particle column. Yeah. This tool also gives you additional information that would be written on the bottom as a wrap-up, like do we need to add a dwell volume, compensation for isocratic cold step, how much to scale down the injection volume. It also will tell you how much back pressure you have to expect, so you know if my instrument has enough power to run the method, or if I need an instrument with a more powerful pump. These are the formula. They are in the EP, so you can also manually calculate it. If you are not user of Mpower, you will get the same results. Again, what I said in the beginning, please never forget the internal volumes of the instrument are critical to be successful. When we run a UPLC particle like this one here, yes, we need a system which has small internal volumes to preserve the peak shape, else we get the broadening and the peaks run together. I showed you also a Van Dempter curve here on the right bottom, and we have here the flow rates. Yeah, so here, and we are here in a range of 0.5 milliliter flow. This is also why most of the UPLC methods are running at the lower flow rates, because here we have the best separation. Increasing the speed would reduce the separation. That was the first part, the change of the methods. The second part are the calculations, and I will walk us through how we cope with this when we are a user of Mpower. Quite in the beginning, the responsibility to take care that you do the right calculation is with you as a pharmaceutical company. You can't go and say it's the vendor's fault that my formula computed something else. However, we work closely together with the pharma industry. That's why we like to emphasize on this topic, which settings you need to do in the software to solve the problem and to be successful by 1st December onwards. When you're in a processing method within Mpower, where you set up the integration, you have in the System Suitability tab the option to select which pharmacopoeia has to be used to do the calculations. And depending on your selection here, Mpower may use a different formula in the background when processing the data. If you like to view the formula, that your version, whatever version you have, Mpower 2, Mpower 3, Feature 2, 5, and so on, you press F1 here, and then comes the help automatically, and you type verifying system performance, and you're immediately there where the formulas are. So you can really compare with the book one-to-one. Is your version doing exactly that what I need, or is it doing something different? And I have to change the settings here to enforce a specific pharmacopoeia, or engage with a custom field, program one, to do the formula manually. Yeah. We had the change in the resolution. We are moving away from the tangent. We are using the half-width approach. In Mpower, it means that the field USP resolution should not be used anymore. Yeah. This field is using tangent. So remove it from your process methods, from your reports, go to another field, and the field is called USP resolution at half height. So it's already there. This is good. We don't need a custom field. It's also there in EP and JP when you make this pharmacopoeia selection. Danger happens when you say, I want to use all pharmacopoeia. Because if you click compute all pharmacopoeia, it also has to compute a relative resolution, and there is in the database only one cell, relative resolution. There's no differentiation. Is it relative resolution according to EP, USP, JP? And in that case, it will use the tangent method. And this is not what we want. So if you have all, you might need, you have two ways. You either say, okay, I don't use the USP resolution field, I look for half height, or I make a custom field. So let's look on this relative resolution field. Yeah? When we use it, I'd set the pharmacopoeia to European to enforce half-height approach. And here in the processing method, here select which peak should look where. So look to AMQ and your peak histidine. So I make the resolution between the first peak and the third peak here. Yeah? I do not need to delete the peak in between, and Power will tell me the resolution. Yeah. This is the special field where we have to be careful when we work from December 1st onwards. Because as said, all and the Chinese pharmacopoeia uses the tangent approach, and only with EP, GP, and USP pre-selection you get it. It was initially not intended that when you select USP pharmacopoeia that it's calculated, but however Empower is doing it. Yeah, that's a lucky coincidence that the USP pre-selection still computes the half-height value. It may be that due to any reason you're not allowed or cannot make the selection EP, USP, or JP, and you must be stuck on all or Chinese pharmacopoeia. And if this is the case, we need to use a custom field to get the correct resolution calculated. And this custom field you can compute yourself if you want, or you ask us to help it. It's outlined in this record file here, how the code looks of the custom field. So you go to support.waters.com, you type in CR1/4304, enter, and you get the full description how to set up the custom field to make the calculation. And once it's there, as I added it here, it does, and again, the correct result, even if you select all pharmacopoeia or Chinese pharmacopoeia. The next is the plate count, which is renamed as plate number. Here, also, the USP plate count field should not be used anymore in the reports. And for evaluating your results, it has to be the field that is computed with EP or JP. So EP plate count, JP report. Plate count has to go into the report, and also in the report, please rename it that it's printed as plate number, not as plate count. The symmetry factor, there is no change in the formula. This is good. It's just a fading out of the term tailing factor. So we are good with all the settings. We don't need to do anything in the processing method. Whatever was is still fine. We can continue to use it. Signal to noise calculations. These are pictures taken from the USB. On the background you see Be Official. This is because it's not December 1st yet. On December 1st this Be Official water sign is gone and there's only official left. And we have to do 20 times the width of the peak. Yeah? Preferably from the injection of a blank. So we inject the blank, we inject the standard, then we measure the width of the standard at the half height, and then we see, okay, it's 0.1 minutes, x 20, and then we know how much noise we need to collect. There is also the possibility still to use 5 times the width, only in the case you cannot acquire data because you have peaks eluting before or after, and this can in certain cases also be the case in a blank injection, because if you have matrix peaks eluting before, which coming from the mobile phase, how you should then acquire there the noise. In that case, and only in that case, you could do 5 times the width still. In Empower, the width selector has to be changed. Yeah? The default is 5 when you open a processing method, and this is something manually to do. Please change this to 20 and you're fine. Also here, as we record nowadays then more noise, it means that our detection limit and quantitation limits are compromised, certainly, because collecting more noise means more risk that we get a worse value in signal to noise, because the likelihood that we get some outlier here on the top or to the bottom is higher, because the noise is peak to peak from the lowest to the highest, and the more I record, the worse the result will be. Yeah? The same is, by the way, with the data acquisition rate. So if you run with 10 data points per second or 20 data points per second, you change the signal-to-noise result. And that's why also I do not recommend to run like 80 data points, 80 hard. That is too much. So 20 is quite fine for UPLC, 10 to 20, and in LC typically 2, 5, maximum 10 points are the good values here. This is a wrap-up table here, again, just as a quick overview of that what I talked about before, which calculation is used by Empower at what point in time and selection. Remediation, how do we cope on the long run with this formula change? Yeah? The first is, of course, look at the processing method, change the pharmacopoeia selection if needed, look at the report method, rename plate count to plate number, probably change the views and view filters in your project, not to display anymore the values that are not needed and replace them with the half-height values. And if you have custom fields that used any of the tangent results, tangent peak performance data, replace it with the half-width. Yeah. Waters will not change the built-in formulas in Empower. This decision has been made already due to data integrity reasons. Yeah. When you process, imagine you have the case, a deviation happened and you have to reintegrate or reprocess results which are 5 years old. It would not use the formula which was effective 5 years ago. This is why we cannot change the cells. We can only add new cells to the database or add custom fields. So what we will, and this is what is proposed internally at Waters for the new versions to come, that there will be, that's the idea, a field called USP, plate count, and then brackets opened, and the release date, also the version of the pharmacopoeia bracket close, and then it's clear which book version was used. This is the idea. And the other one is that in the future version of Empower, the default multiplier in the processing method will be set to 20. This was the biggest change, yeah, I can say. There is another part left, good in time. It's the addition of a chapter, implementation of pharmaceutical procedure 5.26 in EP. There is no equivalent in the USP, but something's a little bit similar, the 1220 about method life cycle. The purpose of adding this was to give an approach for the implementation of a method to your lab. On what should I look when I implement the new method? What do I need to do? Yeah, and it makes some clarification in the terms. So verification is actually the experiment. When you run the sample set with your system suitability standards, the assay, the related substance test, whatever method it is. And implementation are the tasks that you do before. So your assessment. Do I have the right equipment? Do I have the right quality of mobile phase? Do I have trained people? Do I have balances? What is the accuracy of the balances? Is the equipment that I have suitable? Environmental conditions? All of that, so the complete picture. Versus the verification is really only this one sample set that we run in the chromatography. They say assess what factors are critical, what can change the output of the method. Yeah? And one example I can give you is if you use a pipette, which you can adjust the microliters exactly, or you use a stripette with the pipette bore, you will have a completely different accuracy and reproducibility. So it goes into this direction. Assess what is critical in your laboratory, and if you think that can bias your accuracy and your precision, make experiments to verify if that what you use is the suitable and the best equipment for this to satisfy the needs of the method. Yeah. They also say that if a monograph is under a revision of the European Pharmacopoeia, please make the assessment again, which is logical because maybe there was a change in the sample preparation and then you need to look, do I have vortexer machine or centrifuge there, how does this instrument perform? Identify all the critical factors in the actual conditions when you implement the method. Which factors are it? The composition of the article under test, the complexity of the sample preparation, the reagents required to run the procedure, the laboratory equipment, the laboratory environment. Environment is not just the humidity, it's also how is the skill level, trained analysts, SOPs, everything, yeah, the complete picture. In USP 1220, the other book, there's this chapter, Analytical Procedure Lifecycle. It's addressing mainly how we should develop a method from the beginning. So it's talking about an analytical target profile, like you need a method set up to quantity, let's say glucose in this and that matrix, in this and that concentration range. It does not in stage 1 tell you what technique has to be used. Is it GC, is it LC, is it thin layer, is it something else? It's not mentioned there, but it just says in the beginning you have to define the target profile of your method, and derived from there you then do research which methods are suitable. In some cases it may be chromatography, and there you would set then up also critical quality attributes factors, as you would set limits what the method really must do. It must separate, baseline separated. If it's an impurity method, it must see the maximum number of possible peaks and so on, and walk through that. And this is similar here in some terms, because we do an assessment what can bias the result. Yeah, balances, vortexing, shaking, all of that. And the best way to drill down is the fishbone diagram. Yeah, look at sample preparation and everything. It's very detailed in the USP. You can use that as a starting point. When we look now very close to the chromatographic method, we may see a lot of things that can change the result. Yeah, it can be equipment with background noise, how precise is the pumping, is the detector okay. These are things we can capture by qualification, annual qualification of the instrument. There's also the chapter 1058 in the book. Please do it. They say the fundament of the good method, even before system suitability, is a qualified equipment that you can trust that it produces the right outcome. The other parts are more related to the analyst, and here we can use also software to check out how big is the impact. We have a product, it's called Fusion software. It's provided by the company S-Matrix, and it's this QBD software. It communicates with Empower. There's an interface, so it can write methods in Empower. And in this software, which is programmed by S-Matrix, you can set up robustness studies. It's not just column 1, column 2, column 3, this and that temperature. You can also make a robustness testing for the sample preparation. So as we see here, a cube for different experiments, you can say vortexing versus shake gently versus steering on the magnetic steerer. How many minutes? 5 minutes, 10 minutes, 5,000 rotations, 10,000 rotations, centrifuge, just 10 seconds, 1 minute. You can set up the test matrix and then run the injections in Empower and compare the results that come out to see what is the ideal sample preparation. And you may use that also to improve a method. Yeah, we did this at Waters for this API here, a USP method. On the top, this very cloudy yellow solution, this was the USP sample preparation. Yeah, and the method often failed in the laboratory. Yeah, of course, I mean, you see there is not really dissolved. Then we went, okay, yes, change the sample preparation a little bit and even filter it, like on the bottom, and then the results were good and there were no system suitability failures anymore. It is possible to improve a method, and it is also possible to communicate with the people from the pharmacopoeia that put the method into the books. There are contact details below. You can send them email. They are very supportive and helpful. I did it myself, and I was a user in the lab to contact them about fixing a method. Good. Heat map is a good way to make the assessment. So you might figure out, okay, the humidity in the laboratory is not an issue, but the analyst skill for pipetting are an issue. So it's in the heat map, it's red, because if you do a pipetting error, it's going to be a problem. So you would look at this. Waters does provide also solutions to help cope with this. For example, we have the Andrew Lyons robot, which can do the manual pipetting with normal Sartorius pipettes instead of the human doing it. Also nice to the human has then time to do something else, like processing results. Trend chart the results, that is also a good way to keep control of the method, to see if something is going soon into a better direction or not, and to take appropriate measures to fix it. Yeah. Trend charting, very powerful. It's possible within Empower, very easy. It's also a module in the report method that you can drag in for reporting standards and what the outcome was. When it's about the columns, for all our columns, we also sell so-called QCIMs, Quality Reference Material Standards. We use them in the factory to test our columns before we sell them. You may consider also buying one standard of it, if you like. Reconstitute, aliquot, put in freezer, it will last for a year or more. To just check if the column, the stationary phase of the column is still as it was when you got it factory new. This is very important if you are in an R&D environment, if you develop methods, because you must trust that the ligands and the stationary phase was not damaged due to some injections that happened at some time before by someone else or in the recent past. Yeah, assessment and outcome. You do the assessment. If there are no critical factors, then you say everything is perfectly fine in my lab. You just run the method, you do the verification. And only if you say there are critical factors, you do this testing, this robustness study. There's also a table inside what tests are really needed for verification, and that depends on the method itself. There is very little work to do when you do an identification method. So it's mainly just the specificity, spiked, unspiked injection, see if you see really look at the real peak. And it's gonna be more points if you do assay, and if you do assay and impurities, then you have to look at everything of the method. Yeah. And with this, I came to the end of the presentation. The information, most of the information is available at waters.com and at the support website, the Knowledge Center. But as a bonus for you as participant of this event, the original chapters in authentic text from the USP and EP will be shared with you together with the presentation. So you don't need to buy now the USP or EP or to pay for the subscription key. We are sharing the documents with you. Thank you.